Awesome. Thanks everyone for joining today. This is Finger Flyer Educational Drone STEM Kits presented by me, Jacob Parker. I've always been really passionate about quadcopter drones. When I was younger, I was just fascinated about that type of technology. And for someone who's getting started, there's really two main options. The first one is to purchase a high-end, expensive drone. Usually they have cameras on them. They're used for photography. They can be upwards of, $1,000. And then the cheaper, more common option, which young me went with, was buying a cheap Walmart quadcopter drone with finicky, unstable control. Ended up crashing and breaking it within the first hour that I got it and tried it out. So not a great experience. And I thought, there's got to be a better way to introduce younger people, beginners, and then for the educational drone STEM kits, students to this kind of cool technology, not only in the flight and operation, but also what's going on and understanding the physics and the engineering and the overall STEM behind something like this. And certainly in the last decade, they've only become more prevalent and more common in across lots of different industries. And I think that even beyond quadcopter drones, this is a really great way to introduce students and younger people and beginners and I guess anyone of all ages, right, to this kind of cool technology and foster a wider appreciation for STEM and how these concepts in practice really work. The Finger Flyer drone, I mentioned the two main market, the current solutions right on the market. The Finger Flyer drone is different in that it's controlled purely by the user's hands. There's no traditional controller. It's controlled with hand gestures and then our patented fingerport board. So it's kind of like a hoverboard for the hands. You can see the infographic goes over just a few of the main things that it can do. It can be passed, rotated, raised, toss, takeoff. Within 60 seconds of unboxing this, you put the battery in, toss it up gently, and it locks in its position. From there, you can use the aforementioned gesture control sensors or the fingerport board and some of the cool stuff you can do with it. Personally, some of my favorites is spinning it and flipping it with that fingerport board. And another thing that's really unique about this drone that sets it apart from some of the other stuff on the market is it's a shared user experience, right? When you have a controller, when one person has that controller and is trying to figure out all the different joysticks and the buttons, in addition to maybe being a little bit difficult for a beginner to use, only one person can use that at a time. Whereas a Finger Flyer drone, if you have a group of students experimenting with it, playing with it, or working on the lab activities, everybody can experience that flight because it's gesture control sensors. And once you pass it to another user, now they can be in control of it and, do different hand gestures, engage that fingerport board and, do a bunch of neat stuff with it and then pass it off to the next student. I think one thing that's worth noting and kind of some of the feedback we've gotten from the schools that we're in is it's COVID friendly in the sense that if, you don't want a bunch of people touching something, you can just use the gesture sensors, and that way you're cutting back significantly on the amount of lab equipment that's being touched by multiple people. We'll hop on to the next slide. So this is basically, I went into a little bit of what it can do. Unfortunately, since we're not in person, I can't be demonstrating it. I'd probably, if we were all in the same room, I'd just be playing with it the whole presentation. But this is a quick video to kind of give a better idea of what it can do and how this novel, fun, exciting innovation works and how it looks in action. So play that for you guys. Awesome. Glad the sound worked. The last session it did not, so hopefully that'll be in the recording. A little bit about the team. So I realized I didn't really introduce myself too much, but I wanted to save some of that story for after I got the chance to go over the invention itself a little bit. Erin Moore, unfortunately, couldn't join us today. She is a current student at High Point University, majoring in education, has some experience teaching in the classroom. And she was the one who initially proposed the idea of creating these finger flyer STEM kits for specifically educational purposes in school, and has helped work on the guided educational activities, the labs, the worksheets, quizzes, tests, and everything that comes with that educational package. Me, on the other hand, I just graduated Georgia Tech for mechanical engineering. Really excited to be out, pay off some of those student loans. And I'm the inventor of the finger flyer technology, worked on the patents, getting the manufacturing set up. And then the two of us work on getting these out to schools. That's our main focus now. We're continually working on labs, and it's a really great pair. I'm really thankful for this partnership. Getting an engineering perspective, I often focus on the details and the technical aspects, but getting education and teachers' perspective on it has been so helpful and eye-opening to be able to really get the best. And get the best, most optimal, I guess, combination of our two skill sets for being able to communicate to all different types of learning styles in the classroom and outside the classroom for inside and outside the classroom learning. It's just been really great. This was developed, Finger Flyer, the technology and the product was developed during my time at Georgia Tech. Some of those clips that you saw in the last video was up on kind of the Shark Tank version, or the college version of Shark Tank. They helped fund this idea and help us take it forward. They were very supportive, and I think it being a student and going through this was in being, I guess, propelled by the teaching staff and the faculty is part of. It really built itself closely with the mission of this. I mentioned earlier how passionate I am about quadcopter drones specifically and just cool technology, but I think it's greater than that. And kind of the mission of Finger Flyer is beyond just quadcopter drones, really trying to spark that same passion and fascination with STEM that helped guide me into my educational background at Georgia Tech and engineering, but also my broader career. I'll be working at Boeing as well in the next month. I've interned there before, so that another big aerospace company. And these early experiences, right, with even my kind of crappy one with the cheap drone that broke, even though it didn't go super well, it got me thinking about well, this is cool technology. Look at the power of STEM. Suddenly all these, concepts that I was taught in school that I was wondering, scratching my head, why are we being taught this? They made sense, and that's one thing that the labs really try and emphasize is, as students are going through this, their assembly and flying it, it's bridging that gap between kind of some of the more abstract things, in mathematics and STEM, and then showing them with a hands-on real experience, oh, that's why we're learning that. So that's a little about the team. Maybe got off topic a little bit, but this next slide, we'll go over the STEM kit specifically. So this is part of what's included, kind of the main stuff. There's a couple other things we throw in, some manuals. Obviously, the educational plan, which we'll talk about in the next slide, is a lot of stuff there. But in terms of the kind of the physical stuff you get, this is most of that. You get the drone, super durable, super safe. We offer, a guarantee. We sold to a couple hundred hundreds of drones to a couple dozen schools across the East Coast. Have not had any returns or any problems with them breaking or anything. They're built to be durable. That was part of my early experience that I mentioned. I want to make sure that these would, stand the student beginner stress test. But yeah, anytime anything's broken, we always offer to replace it, but none of those yet. But we'll see. I definitely don't want to test students. I'm sure they'd find a way to smash them. You can see there include extra propellers, high-performance battery, USB charger, and it's not shown here, but we have an emergency shut-off clicker that's included for teachers if a student, if it gets away from them or they don't want to shut it off or whatever, just to give the teacher control to shut them off if they need to. And then you can see multiple, we call them top pieces. Basically, these you see the finger port, propeller guards, and then also the blue piece on the end. They're all they're with these guided labs. They're attached and detached at different points to kind of experiment with different types of flight performance and different types of sensors, and really provide the student a lot of different ways to customize their learning experience and continually be interacting with the drone outside of just flight, but actually, as you can see here, it's opened up. They can see the circuitry and work on that assembly. That's one thing that really makes this unique. There are a few other educational, STEM kits on the market for quadcopter drones. I haven't seen any that really include both everything needed to assemble, fly, and experiment. So a lot of times you'll need to solder something or you'll need outside tools. In each kit, we have everything needed to go through this, the assembly, disassembly, customization, flying, and experimenting. So we don't expect the classrooms to have anything else necessarily. We have that all in the package. Then also, the only one that I could find that has a ton of guided educational lab activities. So this kind of curriculum, we've seen teachers just go through. We'll get into it in the next slide. I think I misspoke earlier, but this next slide will go over the outline of the topics we cover. We've seen them adapt into their own curriculums. We've seen them just follow this curriculum. And as an engineer, I'm probably not using curriculum I'm probably not giving it quite the same rigorous definition that maybe an experienced educational professional has. But these lab activities, these quizzes, these tests, the different, all this different educational content can last easily 5 weeks if that's all that's being done in the classroom. And I think without further ado, we'll get into some of that. I included just a few of the figures on the labs. I mentioned this is kind of divided up into 5 different topics or 5 different areas, but it can easily last 5 weeks or more, depending on how you're kind of splicing it into your current classroom and curriculum. The first thing we do is the Intro to Technology section, and basically we don't want to assume that any teacher or any classroom or any students necessarily, we want to assume, okay, if someone's walking in this with no experience with drones or even, these kinds of STEM principles, let's walk them through the vocabulary, the basic, flight and operation of quadcopter drones in general, and just get them caught up to speed with this kind of terminology. You can see in the bottom left, that's just one of the figures in that part of the lab. These labs can be viewed at fingerflyer.com as well. Not the answer keys, because we don't want students getting on there. But I'll make sure to drop that in the chat. On the last slide, there's also a bunch of resources to look further. But you can see that's one of the figures, just pointing out different things on the drone and the insides of it for students to be able to understand what's going on underneath and identify those components. Then we go into physics of motion, forces, feedback diagrams. And then, I mentioned this earlier, but we go over these kinds of things, and I remember in school, why are we learning about this? The motion part of it and the hands-on interaction part is, you do something on paper and kind of do out some calculations and feedback diagrams, what's going to happen. And then it's, we really have a strong emphasis on, okay, now test it, do this with the quadcopter so you can see the bridge between what you're learning and real world application, which is, so important for students to not only feel like they're applying what they've learned, but to have that real world experience and feel like they've conquered something. Not only do they know the concept, they've proven it and they've kind of conquered that challenge in the real world. Something that's really unique about this specific, these specific labs and the opportunity offered by these STEM kits. Then we get into the aerodynamics of flight, the sensors and design. That's personally one of my favorite labs. That's super fun. And then one thing we're working on right now is the entrepreneurship end. I mentioned I did this throughout college, and with patenting and manufacturing and trying to license, there was monumental failures along the way, and I definitely learned a lot. And I think that sense of conquering a challenge was really shaped by there's no roadmap really for patents and manufacturing. That's one thing I want to instill. I want to instill that specific confidence in students. It's kind of an optional, lab activity to walk them through that, and let them know that their ideas are important and they can do this. I wasn't anything special. It was just these early experiences throughout high school that helped shape me. That went on into college, on this kind of engaging technology, being able to interact with it, feel like I understood it and applied it, and that carries outside of even just STEM specifically, but an overall confidence in being able to take what you've learned and apply it, and conquer a challenge. Get on to this next one. Yeah, so this is the contact us. This is basically the end of the presentation. I wanted to include the website. There's a bunch more videos, information. There's a whole tab for STEM kits that I definitely encourage everyone to check out. You can email me directly at fingerflyherboards@gmail.com. That's a little bit much to remember if you don't write it down now, but if you write down fingerflyer.com or you check it out, you'll be able to contact me, be able to see all the information. That's really the main thing that you need. For any questions, or I'll take questions here in a minute. And then also this is my personal phone number. If anyone wants to reach out for any reason, I'm more than happy to take a call. You've listened to me ramble through this whole thing. I could easily talk another 30 minutes, a full hour, if I wasn't stopped by time limit. So I'm more than happy to talk with anyone who is interested. I think that's going to conclude the presentation. Hopefully I hit everything. And now I'll answer questions. Thanks so much for your time. I really do appreciate it. And yeah, have a great rest of your day.